Alright, here is the quiz review for Monday's quiz. There are 3 primary topics on this quiz. First, static equilibrium. To review for this, you need to be able to perfectly and quickly do the free response from last week's quiz. I've even posted a copy of that free response question on the website in this post. There's a free response question on this week's quiz that is similar to last week's free response section, so be able to do that. That's all I'm going to talk about the static equilibrium part. Next, translational equilibrium and friction. If we've got something sliding at a constant speed, you need to be able to either find the force of friction or the coefficient of friction between the thing and whatever it's sliding on. And just so you remember, force of friction is given by the equation mu times the normal force. And mu is either static or kinetic, depending on if the thing is moving or sitting still. So in the case of translational equilibrium, if it's moving at a constant speed, that is mu k for kinetic. Then, inclined planes. You got to remember that trick to rotate your y-axis, your xy axis, so that it is perpendicular in y to the incline, the ramp, and parallel in x to the ramp. And I'll do one example of friction and one example of inclined planes. This question was on one of your homework assignments, and it is very similar to a question on the quiz. So let's go through it. A spring scale reads 15 newtons as it pulls a 5 kilogram block across a table at constant speed. Constant speed, your mind should automatically go, this is an equilibrium problem. Anytime you see constant speed or at rest and there are forces involved, that's an equilibrium problem. What is the coefficient of kinetic friction between the block and the table? So the problem wants me to find the coefficient of kinetic friction. Okay, well, like I said, this is an equilibrium problem because it says it's moving at constant speed, and I know there are forces involved. Therefore, my up forces equal my down forces. My left forces equal my right forces. Okay. Now let's start listing forces. I'll do up and down, or Y, in blue. For my up force, I see 2 forces. There's the normal force, and then notice this vector P, part of it points up, so we need the up part of P. The up part of P would be P sine theta, so that's the Y component of P. That's equal to, both of those things are equal to the weight, W, and W is another way of saying Fg. So my down force is my force of gravity. I don't see any other up or down forces. Next, left and right forces. There's a force of friction to the left, and to the right there is the x part of P cosine theta. Okay, I am trying to find the coefficient of kinetic friction. So let's think about what I'll have to know in order to find that. Force of friction is mu, and if we're doing kinetic, K, times the normal force. Right now, I don't know any of those things. So I've got to find the normal force and force of friction in order to find mu K. So let's get busy. First, I notice that FF is P cosine theta. So FF should be pretty easy to find. Let's look back at our problem and list the givens, see what we can get. My spring scale reads 15 newtons, and that's what's pulling, so the pulling force is 15 newtons. The box is 5 kilograms. That means the weight of the box is 50 newtons. Should be able to find Fg in your head like that by now really fast. 5 kilograms of mass is 50 newtons of weight. Okay, so I could immediately find FF by plugging in for P here. So FF is 15 newtons times the cosine of theta. Since theta is not given, that's as far as I can get right now anyway. So now I know FF. I now need the normal force. So taking from the up and down part, to solve for the normal force, that's normal equals Fg minus P sine theta. I just subtracted P sine theta from both sides. We know those numbers, or some of them. N equals, weight was 50 newtons, minus 15 newtons times the sine of theta. So I could then sub into the equation for force of friction. I'm running out of room. I'm going to color code to bring this down. Let's do force of friction in purple. So I have found FF, and I have found the normal force. We're looking for mu k. So let's go ahead and solve that equation for mu k. I'll divide normal force on both sides, and I'll get F over normal equals mu k. Now let's substitute in what we found. FF is 15 newtons cos theta. Normal force is 50 newtons minus 15 newtons sine theta. And if the problem gave me the angle theta, which this one does not, I could then just plug in for theta. For those really looking for a challenge, there is actually enough information on this slide to find theta. You do not have to be able to do that level for the AP test or for my quiz tomorrow, though. All right, next example. The diagram here shows a 10 kilogram mass held at rest on a frictionless 30-degree incline by a force F. What is the approximate magnitude of force F? Before we solve this problem, let me point out something really silly, but potentially tricky that the educational testing service, the people who make the AP exam, did here. They called this ramp frictionless, but then they gave you a force that would basically be friction. That box wants to slide down that ramp. Whatever this force is keeping it from sliding. So that's basically a friction force. But to placate or satisfy the ETS people, we will simply call that a force F. That, according to them, is not friction. But if you were solving this problem, you could just treat that F like friction, and you get the same answer, because it should clearly be friction. Moving right along. First off, we need to take our XY axis that we would draw for this problem and rotate it so that it is parallel and perpendicular to the ramp. So let me try to do this as straight as I can. There's my y-axis. Here's my x-axis. Now let's draw the forces that we know are on that box. Because I drew my axis in black, let's draw the forces in orange. Gravity always points straight down. Be careful here, you might be tempted to point gravity along the negative y-axis, but we've rotated that axis so that gravity is not along it. The normal force points perpendicular to the surface, which in this case is along the positive y-axis. Remember, we rotated that axis so that the normal force and what would be friction would line up with our axes. There's a force simply called F going in the positive x direction. So we've got normal force in positive y, F in positive x, and gravity pointing straight down. As I've shown before, the angle here on your incline is the same as the angle between gravity and the negative y-axis. So this is also 30 degrees. All right, we are looking for the magnitude of force F. Well, if you remember, since this thing is held at rest, this is an equilibrium problem. F up equals F down. F left equals F right. My up, or better yet, positive y forces are normal force. My down, or better yet, negative y forces are the y part, so the part of gravity, let me switch to a color here, the part of gravity that falls along the y-axis. That part of the force of gravity is adjacent to the angle, and so that would be a cosine part. So my down force will be Fg cosine theta. My left force is the x part of the force of gravity, the part that points to the left. So that would be opposite the angle, which would be Fg sine theta. And my my right force is the force that we've called F. I'm trying to find F, so it looks like I could do that really quickly here. Fg from a 10 kilogram mass would be 100 newtons. Now be careful, if this problem had said a 10 newton mass, sorry, not mass, a mass with a weight of 10 newtons, so if this information had units newtons, that would already be a weight. It has units kilograms, so we have to find its weight, but if it had units newtons, it would already be a weight. And the AP exam can easily trip you up that way. It might give it to you in newtons, you'll think that's a mass, multiply it by 10, and it'll be wrong. If it gave it to you in newtons, it's already a weight. All right, 100 newtons times the sine of the angle, 30 degrees, equals F. So now we just have to do 100 newtons times sine 30. 100 times the sine of 30 is about 50 newtons. And so F is about 50 newtons. If I look back at my answer choices, the one that's closest to 50 newtons is number 2. And we're done. Be sure to look at the quiz free response from the last quiz, and good luck.